So, welcome back. Last week, the ethics and moral of sustainability. Today, circular economy, which was your homework. So I hope you all watched the circular economy MOOC video. And the only answer now is yes. So some very intensive nodding would be appreciated. Today, our second invited lecturer, Daniel, the person who brought circular economy to the university, is going to give a lecture essentially building on top of what you've watched at home as part of the MOOC video. So now you know all the foundations, like all the basic concepts of sustainability, of the circular economy. And now it's about, okay, how do we get there? It's nice to have that concept, but how do we get there in practice? And without further ado, Daniel Goldmann.
Thank you very much, Benjamin, and hello, everybody. Oops, I just try to do it this way. I hope that's okay.
We'll see.
Can you hear me? Yeah, I hope so. At least you can hear me, I'm sure. Well, what I would like to do with you today is first we start with a lecture, and I try to give you some ideas about developing circularity. How do we get there, and where do we have to get? Let's say, where do we have to be in about 30 years, approximately? Because you are the ones who have to drive that until this time. And in the second part, I would like to do something with you, kind of World Cafe. I don't know if you know this format, just to develop your own ideas. And we split in two groups, and we have two questions that you could work on. But first of all, I would simply start. I guess I can take that. I would just simply start to give you an idea on how to get to the goals that we have to go to, and to give you an idea why this is so essential. So yes, so I will start at a very high level, so to say, well, the challenge and the solution, and well, specifically if you look around and look what's happening politically worldwide at the moment, it's a pretty unpleasant situation. So we talk about insufficient education, no equal opportunities, less social cohesion, missing sustainability, massive resource consumption, rising CO2 emissions. And that leads, in fact, to quite a lot of problems. As you can see, climate change with species extinction. We have intensified migration due to, well, flooding and so on. Intensified critical land use. We have extensive extensions of man-wildlife boundaries, and the result, well, you all have seen in the corona pandemic. So kind of pandemics through zoonosis will be around in the next decades again, I'm afraid. Well, in the end, we have threats to peace and democracy and nationalism. So what could we do with our activities to work against these threats? So we need a change of mindset. We need a change of behavior. We need a decrease of world population that fortunately is going to happen. I show you now in just 1-2 slides what actually happens. Reduction of resource consumption, that's absolutely necessary. Increasing cooperation. Unfortunately, if you look around worldwide, it's going in the very opposite direction, but we have to change it again. And we have to end up in something like post-growth economy. Actually, the final thing is what we call in German Gemeinwohlökonomie. That's coming up. So to reach all of these topics here that you see in this part is necessary to end up here in the circular society. What does it mean, and how do we get there, and what are the framing general conditions? First of all, let's have a look on the development of the world's population. So when we look back to the 80s, we had about 4.8 billion people. Today we are 8 billion people, but it's not a disaster coming up. What we see, or what you can see here, is those green parts are the growth of population. It's going down. Already since approximately the year 2000, the amount of growth in the population is going down. That means we will reach, maybe the latest dates are at about 10.4 billion people worldwide, maybe 2070, 2080. That's the latest numbers we got from United Nations. Why is that so? Because some of the biggest countries already start to, degrow. So say if we look at China, China had its peak about the year 2020 or 2022 with 1.4 billion people, a bit more. And now, since then, the number of people is decreasing. By the end of this century, they will be down to about 850 million. That's due to this one-child policy. But also other big countries like China, that is at the moment, like India, that is at the moment the largest country, will start to decrease in the population approximately in 2030, because what we see now is that the number of children born per wife, normally you say 2.3 children per wife, keeps a society on a stable level. And in India, we are below 2.3 already. Just since people getting older now, population is still rising, but what you can see is the effect that the complete population will go down. In fact, actually, there's just one continent where the population still rises, that's Africa. But also we can see there changes in the development. Well, what does it mean for us? First of all, if the number of people would climb and climb without an end, it would just be the question when the disaster will come, but we have a chance to survive it. And what our topic is, we have to look at the consumption of raw materials, energy, water, and space, because those are really relevant topics. And what that means, I'm gonna like to show you in the next slides. First of all, it's important to understand that the amount of raw materials, for example, is not rising in the same dimension as the number of people is rising. It's much more. Why is it so? Because if you look at those numbers from, oops.
Keep talking, please.
Okay. If you look at these numbers, you will find, for example, that in the year 2010, it's not that we don't have newer numbers, but on the global level, we normally work with some levels, 2010, 2030, 2050, 2070, to get an idea what really happens. And if you look at that, you find in the European Union, we had a raw materials consumption per capita per day of 43 kilograms. And at that time, if you look to Asia, Africa, that was 14 kilograms, 10 kilograms, something like that. Meanwhile, for example, China is far beyond that. Some years ago, China already had 33 kilograms per day. Meanwhile, I guess it's beyond the 43 kilograms. So it's not only the number of heads, but it's the consumption per capita. And that means that the overall consumption of raw materials is rising dramatically. In 2010, the expected numbers have been, rising from 60 billion tons of raw materials per year up to 100 billion tons in 2030. But in 2018, we already knew it's larger than that, because in 2018, we already had 90 billion tons per year. It was actually rather expected for 2030. So the number is rising and rising, and the question is what to do with that. Besides these general numbers, it's also important to talk about actually what raw materials are we talking about. And that is also a thing that makes a difference. For example, if you run a coal power plant, you need concrete and steel to build it and coal to run it. It's, of course, a bit more. But if you change, for example, to wind energy, plants or to solar photovoltaic plants, you need completely different materials. You need rare earth elements, you need large amounts of copper, you need indium, you need gallium. So we change the materials that we are working with. And the major drivers, for example, are digitalization, electromobility, and new energy conversion and storage technologies. So the question is, why digitalization? Is it not a dematerialization? No, it's not. But because, of course, we do quite a lot of things in the internet, but to do this, we need server farms, huge server farms, and you can't build them just out of air and love. You need these materials exactly to build these server farms, and that's the reason why also digitalization needs large amounts of raw materials. Electromobility is very clear. If you change from conventional cars to electric vehicles, you change also the amount of material, you change the materials you're using. And just to give you one example, if you look at a conventional car and look how much copper you need for the car, and you look at an electric vehicle, you need 5 times as much copper for an electric vehicle. And if you also look at the loading infrastructure that you need, you're approximately at a level you need 10 times as much copper for mobility as you used to have it for conventional gasoline-driven mobility. New energy conversion, as I already mentioned, for example, wind power plants, photovoltaic, and so on, and storing technologies, battery. Everybody has heard about that big problem. If we change to lithium-ion batteries, where do we get the lithium? Where do we get the cobalt and the nickel from, specifically in these dimensions that we have? So we are talking about quite a lot of elements are comparatively scarce that we have to look at. How scarce and how critical those elements could be, I would like to show you in this chart. What you can see here is for some elements. Meanwhile, you could prolong this list for plenty of other elements. Just a very short snapshot on that. For example, you see gallium. And what do the numbers say? In the year 2006, we used 18% of the world production of gallium for thin film photovoltaic, IC, that means electrics, and LED. If you look at the development on photovoltaic, on electronics and LED technology, we would need in the year 2030 about 400% of the world production of gallium. Of course, of the world production from 2006, but whoever is acquainted with the mining sector, so to say, you would see it is impossible to raise the amount extracted and processed to such a level just by mining. It takes very long and the resources are critical. Well, gallium is actually not the worst case because we still have, on a geological level, potentials. More critical would be indium, and what is every day in the newspapers, you can read about it, it's lithium, it's cobalt, it's nickel, and one other element that tends to be a very critical element if we talk about hydrogen technology. Putting our efforts and producing hydrogen, we need an electrolysis, and the most modern version is a PEM electrolysis. For PEM electrolysis, you need a catalyst that is made up of iridium. Well, iridium is a very rare element, so the world production of iridium is approximately 6 tons per year worldwide. To run hydrogen technology based on PEM electrolysis in a moderate dimension, you would have to raise it by a factor of 3. That would mean we would need 18 tons of iridium. Doesn't sound so much, but it's limited. And it's really the question if we have these materials. There's just actually one area in the world where you have 90% of all iridium. It's in South Africa. And if something goes wrong, we really got stuck. So we have to look at those points as well. So as you can see, it's tricky. And therefore, the answer is, at a first glance, circular economy. That means I have to try to get to the point, how can I get raw materials out of the ground in a decent way that also goes with social license to operate, because you can't ruin all of the planet just to get everything out there. Then we have to design products, because the question is, do I need that much of this material to get to this effect that I want to have from this product? Then we have the production and remanufacturing. There's also something to do. Distribution, logistics, big issue. And then we come to the area where we are normally working on: consumption, use, reuse, repair, the so-called 10R strategies. We have to look at collection, and then we can go to recycling and to close the loop. So, in fact, the circular economy is much more than just starting at that point where we have already the waste. You have to rethink the whole story and start from the beginning. And what, of course, is still left over, there will be, of course, always a little bit left over that you don't want to bring back into a circle. For example, if you rip down a building and there's asbestos in there, you don't want to recycle it. Most certainly not. But we try to keep that at a minimum. Well, that means a circular economy, if you look a little bit closer, will satisfy, or will contribute at least, to at least six of the 17 SDGs, Sustainable Development Goals of the United Nations. Of course, decent work and economic growth, industry, innovation and infrastructure, sustainable cities and communities, responsible consumption and production, and so on. So, in fact, dealing with these materials and these points that we talk about, it makes really a difference. So, what do we need? We need to secure the raw material supply and resource efficiency as a major goal of the century, to make sure that we, in fact, that's the way we are going at the moment. That's the linear economy. And we have to bring it back, because in the end we want to live here and not there. And that means it's a combination of four major pillars. It's, of course, efficient and sustainable primary raw material exploitation. It's the raising of material efficiency in high-performance products. It's recycling, and that's what I talk a bit more in detail, and it's substitution of critical raw materials in relevant products. Well, due to the growth in countries like China, India, and other developing, well, actually, it's developing countries is the wrong name. It's still called like that, but it's meanwhile, I said the countries of the future. Because if you go to these countries, and I just came back from Brazil, and if you see what happens there, it's very clear. It's just a question of time until they will be ahead of us in many times. And it's the same in many, many countries of the so-called Global South. That they are really good on the way. But due to the growth in these countries, raw material supply will be a massive cost driver. Well, we have seen the number of the per capita growth, and the number of people is growing, and the consumption means also that everybody needs these raw materials, and that's a so-called CRB, raw materials index. That's an old one, but it looks always the same. If you look at the other times, normally the raw material prices are following something that is, it's kind of a curve looking like that. Because price is low, so nobody does anything, then we have a shortage of material, price is going high, everybody starts exploration and mining, then it's going down again. Normally it's something like that. But if you have time enough, and put a line through this, it looks like that. It looked like that. It was until approximately the year 2000. Meanwhile, we had seen a change, because we still have that, but it's going more or less like this. So if you go with a line up, then you see that the development of prices really makes a difference. It's rising. Not if you work at a If you try to earn your money when trading shares or whatever, might be a difference, but if you look at the long-range development, it's exactly what happens. So economic crisis could interrupt, but not break these developments. That's also the question with respect to wars. As long as we don't have the Third World War, then everything would be different. On the other hand, in highly industrialized countries like Germany, but also in growing economies like China, Brazil, large amounts of waste streams accumulate. Yes, because everything we take out from the nature, out of the earth, is not gone. It's just changed. Everything we don't eat or burn is still there, but in a different way. It's just not a primary raw material. It's a kind of waste, secondary raw material. So this is actually more and more important to be our source of raw materials. Of course, due to the growth that we have seen, it's not possible to say, oh, well, we put everything on recycling. We need both. And the first calculations when we could start working only with recycling for the first materials could be around 2080, something like that. Because when population goes down and when efficiency has gone up, maybe. But until then, we need everything of these 4 pillars we have seen. Well, having that in mind, it's also important to see why do we deal with these things in Germany, if we talk about worldwide problems. Well, that's the worldwide overall waste generation in tons per day, and not per capita, just per country. And what you can see here is, of course, United States is still they waste everything, yeah, and it's not going to be better in the next 4 years, I'm pretty sure. China is also going this way, but of course China has much more people in there. It's a high developed country. And if you look at Germany, we are just 1% of the world population with 80 million people, but we are number 5 in waste generation worldwide, in absolute amounts of tons. Wow, that's quite a lot. So much for environmental challenges. What we have is technology, and we can use these waste streams as raw materials since we don't have own resources for the most elements that we need for our production. If you look at this in comparison to primary raw materials, and if you look, for example, at one element that has been under use since the beginning of human culture, that is copper, for example, you will find that the copper stocks from the primary resources, that's geogenic resources, is going down. Of course, discussion with geoscientists is that realistic because we are talking about so-called static standard conditions. For example, if you say, if you want to mine copper, and the content of copper in the ore should be at least at 0.4%, and you shouldn't go down in an open pit below 1,000 meters. That was normal standard. Meanwhile, we are at 0.3% copper and below 1,000 meters because you run out of this material. Anyway, we see the amount is going down, and on the other hand, you can see the anthropogenic resources are rising. And what do we understand under anthropogenic resources? Actually, everything that we had mined and that we are using or have used. That means this one, that's so-called active anthropogenic stock, the car outside the building here. And then we have the things we have thrown away and dumped. That's a passive anthropogenic stock. And as you can see, already in the year 2010, we had more copper in the anthropogenic stock overall than still in the geogenic stock. And in 2020, even the second line hit the geogenic resource line. We already have more copper in mine tailings, slags from smelters, and municipal solid waste landfills. So why not mine that? Well, in addition, it's not only a raw materials question. We have improper or insufficient treatment of waste that causes massive environmental damages. Well, you all know this. Littering of plastics in the oceans, that's really a big challenge. Since it's said in the year 2015, we will have more plastics in the ocean than fish. And this, what you can see here, these pictures here and there, for example, are from electronic waste recycling in Africa, specifically in Ghana. There has been the biggest landfill of e-waste. It's the legendary landfill Okbobloshi. And it's a pretty much of a disaster how that is done there, because the poor people running around like that, they can recover some elements with a very low recovery rate, and the most of the other stuff is lost, and besides that, it doesn't look very healthy what they're doing there. So overall, risks, perspectives, and chances. Raw materials consumption will rise steadily. Prices will rise, that's for sure. Not if you try to deal on a stock exchange in a week by week, but if you look at long run price development, it's that way. We have shortages for specific raw materials. They will occur, very definitely. The waste streams are rising, growing. So at the moment well, actually it was from the year 2016, we had about 2 billion tons per year of waste streams, and prognosis for 2050 is about 3.5 billion tons per year. But that was, I have to say, before we had the wars. That means with the wars, the amount is rising, of course, because it's certainly not environmentally friendly what happens. But more and more countries take concern about environmental issues at a big advantage. It's not only us, it's many, many countries. And the question is investments and jobs in raw materials and recycling industry. In fact, there has been a big change. And when, in fact, I started my professional career, I started the primary raw material business, actually here because one of the two big players in raw material generation, raw material companies, mining companies of Germany was here, Preussag. And that time had about 70,000 people working for Preussag, big company in this field. And meanwhile, it doesn't exist anymore. But if you look at the modern companies that developed from waste management to secondary raw material industry, like Redmann Group, Remondes, they have meanwhile 90,000 people working for them. So that's the new way to do it. That's the new raw materials industry. At a second glance, we have seen circular economy, and what you can see also on the right side, that's a nice picture from the Ellen MacArthur Foundation. But that was in the very beginning coming more or less top down. How should it be done? But this circular economy approach describes a knowledge-based, technological, economical, and ecological-driven approach for reorganizing society. But if we just follow this way, it's not fast enough. We can't change the whole story. We have until the mid of this century, we have the time to change the world to a circular society, and it's really just 25 years ahead. We also need the complete population to work with us. And that means we have to look also at emotions. That means besides knowledge-based, rather top-down, we need also bottom-up approach that has to be added, and we have to activate people. So that means a systematic approach to develop circularity. In fact, if we want to end up in 2050 in a circular society worldwide, that would be a big wish. Well, actually, when we started with these ideas, that was before Corona, before the war in Ukraine, before all the other wars that we had, we said, okay, we have to hurry up, but we have a chance. At the moment, yeah, but we have to go this way. Otherwise, Yeah, well, maybe a little bit later, maybe we hope we survived our story. But we know how to deal with circular economy, but how do we bring this into real life? And the only way to get find a path to roll out this is to go over circular cities and circular regions. That means in specific areas, you start with specific topics that you're working on. Develop them in a perfect way and then show the others how it's done. And so, meanwhile, quite a lot of circular cities and circular regions start to develop worldwide, at the moment at a large amount in Europe. And every region and every city works on a different topic because you can't do everything at the same time. I'm going to show you what these cities and regions could do, and after this lecture part, I would like to have you on generating your own ideas how a circular city or how a circular region could look like. But just to give you an idea, what are the drivers? Steps towards a circular society, if you look at a holistic approach, we have to talk about efficiency and sufficiency. Yes, of course, we have the point that we not only can work with efficiency and say, okay, we make processes better and better, but we have to say, okay, we don't need all that stuff anymore, or this amount. That means, for example, shared economy. Not everybody needs to have a car, specifically not if you're living in a big city with a decent, good public transportation system. Well, Clausthal is different. But if you go to Berlin, it doesn't make much sense to have an own car, for example. Longevity. How old can products become? Doesn't make sense to throw everything away. We have, of course, developments that go completely in the wrong direction. For example, in fast fashion, where you buy something that has been produced under terrible conditions in Bangladesh, just buy it, wear it once and throw it away. That's definitely the wrong direction. Refurbishing, cascade use, that's the 10R technology that we need to get down from what can I avoid, refuse, until the point how to recycle that. Then we have to look at avoidance, reduction, prohibition of littering. That's something about environmental education and public policies. We have, and that's important, also to look at mass flow prediction and decision instruments, because if you develop a technology, for example, for recycling of something, and if you want to send up a plant that costs you quite a lot of money, you have to know not only the technology, but you have to know what's your input, what are your competitors, what's your output, and what are your customers. And therefore, we have new instruments to run these things. We need a navigation and control of post-consumer waste streams. It's still the situation that we lose many, many raw materials, for example, from batteries. Collection rate in Germany, it's 45% of batteries. 55% are gone somewhere, but not in a decent way collected. That means we need environmental psychology and behavioral economics to change the mindset of the people. We need waste sourcing and collection systems. That's actually a modern waste management system far beyond of what we have today. We need, of course, our core business treatment processes for recycling technology. And that's still a thing that develops on and on, since if you are a recycling engineer, you're looking what is the next development of a new product, and then you look, okay, I have to recycle that as well. So what do I have to do? So it's always the point that you're going beyond what you have. We need management of complex process change. And that's actually one point that is, I guess, for most of you, a central part. It's digitalization of circular economy. Because if you want to run a real circular economy, that means you have not only materials and products, but you also have information. And if you have this in a linear economy, it's complex enough to run that over a long line. But if you have it in a circular system, it's by square, the number of data that you generate, and you have to deal with these. Otherwise, you are completely lost. So it's the central part that develops together with all the others. Then that's something for the people from economical sciences, trans-corporate networks, because you can work with a small company looking at your revenue, don't care what's before and behind yourself, but if you think in networks and say, okay, we want a maximum value for the complete network, that's fine, but you need new calculation models on the economic side. Then, of course, again, use of recyclates, setup of recycling plants, you need an acceptance. That's what we normally call social license to operate. First of all, you have to bring people to bring their old handy to the recycling plant, and then you have to get people that they accept that the recycling plant is to be built. Everybody wants to have some, but not in my backyard. That's not the way to do it. So we need some acceptance, and that's the point where our social science colleagues are working on. And in the end, you have to run model regions. And this is exactly the point. These model regions, if you have all of that inside, can generate a circular region to run those things and to show how it works, to learn and to see what has to be changed. So that's the point we have to go to. Well, already mentioned circular cities and regions, and now it's pretty important to understand what is the difference, what does it mean? And if we talk about circular cities, we actually would have to understand on an international level. Well, more or less, Germany actually has no cities. It's all flat land. Yeah, it's because in the large countries of this world, we're talking about mega cities. For example, People's Republic of China has more than 50 cities beyond 10 million inhabitants. 50, more than 50. And so with our small cities, it's a bit tricky. But that means cities have a complete different setting than the flat land. But then you have other chances in the, let's say, more or less flat land. Let's look at the cities. What are the background concepts and restrictions for circular cities? It's important to understand that around 50% of the world's population currently lives in cities. Certainly, normally under the definition, Clausthal wouldn't be a city. Sorry for that. Yeah, it's more or less a village. Yes, okay. What is the definition of city? There is no fixed definition. Yeah, it's not that I can say, okay, this is exactly what everybody worldwide would understand under a city. But if you go to China or India and tell, okay, I have some place where 16,000 people live. Okay, well, it's a larger family, not even a village, but yes, something like that. Well, it can be assumed that cities have a significantly higher population density. That's important than rural regions and are generally more likely to grow. We see that in some very big growing metropolitan regions, mega cities. Well, in Germany, we don't have any mega cities. We see meanwhile cities of 30, 40 million people. At the moment, officially the largest one is Tokyo with 36 million inhabitants and 25 million people commuting every day in there, so we talk about 60 million. Others are coming up like that in China, for example. And by the end of this century, Lagos is supposed to have 120 million inhabitants as one city. Okay, that's quite a lot. But that means you have also a compression of space in these cities. And that means, how can I deal in a city? What are the challenges? And in larger, more affluent cities, a shift in traditional industrial production to more services are specified, and specified personalized production could take place. That means, as we had that in former times, for example, I'm coming from Berlin, and we had this called Siemensstadt. In the middle of the town, there was those big industrial complex of Siemens. In future, nobody would build big factories in the middle of a city. No way, no place, no space for that. You go outside for the big plants, For example, if you look at the Tesla plant in Brandenburg, they didn't place it in Berlin, of course not, but on the outskirts somehow. If you say, okay, I have something like additive manufacturing, like 3D prints for personalized things, that's really a thing that you can do in the city just for one person, but you need a small space. Therefore, in circular cities, you have different approaches than in the flat land. So we talk about focus on traffic conversion, emission reduction, conscious handling of food, dematerialization, shared economy, repair, urban gardens, aquaponics, and so on. Those are central points that you'll find there, because the drivers are also emotionally, because it's just relevant what people are caring about. So it's to a lesser extent a technical economical background or a global ecological view for people dealing with that. So it's rather local pollution, stress situation, community building, back to nature, and sufficiency attitude. That's typical for a circular city. It means different circular cities put their efforts on specific narratives, specific ideas. What can we do as a city to do this or that? And afterwards, one group of you would just develop one idea for one city, for example. Some typical activities in circular cities, of course, this is a very important thing. Climate change needs, as a result, that means we need plants on high houses. We need second-hand Kaufhaus here. We need, this is aquaponic, where you have it's in the middle of a train station where you have fish and growing tomatoes and all that stuff. And the fish produce, besides their fish, also their excrements, and you use them as a fertilizer for the tomatoes. So that works very well. It's certainly nothing that you would do in Clausthal. Doesn't make sense. It's something for the cities where you don't have sufficient space, but you need the food without importing it all along from somewhere else. So that's 3D, of course. It's the individualized production. So those are typical activities in circular cities. Coming now to circular regions, that's different. Currently, around 50% of waste is already generated in cities, yes, and 80% of greenhouse gases, yes, but it may not be recycled there to the same extent in the future. So we have to bring them out of the city and do something outside of the city where you have sufficient space. We have changes in the development of modern collection and waste logistics systems, and it will go on, definitely. Pioneers are, for example, Netherlands, that are, well, we have a decent collection system in Germany, but no comparison to where the Netherlands are already. Well, they are normally, with respect to trade and logistics, much better than the guys in Germany. It's traditionally the way. We need more complex and efficient recycling infrastructures, and they are increasingly space intensive and maybe also a bit critical. For example, if we talk about recycling of lithium-ion batteries, traction batteries from electromobility. We actually were still plan a big plant, first big industrial plant around the corner here in Oka. But to run something like that, you need half a square kilometer to run such a plant along the complete chain. And it's tricky since those batteries are potentially explosive and incinerate and whatever. You can't do that in a densely crowded area. It's simply impossible. Well, so having that in mind, we can see that circular regions with a high innovation and value creation potential are characterized by a high density of research institutions and intellectual drivers. You need that to start this. A high density of simultaneous diversity and complementarity of companies in a specific field. the fundamental openness of society to the development of new industrial structures, a suitable geographical location. You can't do this in Antarctica, of course. Yeah, it's no good idea. Because you need also transport connections and availability of space, and as well, you need political frameworks that fit. And basically, if you look at that, and first of all, forget about recycling, you end up here. That's the mother of all clusters, the Silicon Valley. It started like that, and basically the Silicon Valley is not in the center or very close to a huge city. It's more or less somewhere between San Francisco and San Jose. It's a beautiful area. Really, it's really nice, but it was more or less an area where people used to plant oranges and whatever. And then we have some really big universities like Stanford, Caltech, and so on. And we have some companies who started there, and then more and more companies and more research organizations joined, and that's kind of a gravity effect. If you are beyond one critical mass, everybody wants to go there because you learn from each other, you have complementary activities, and you can generate people that you need for your development and for your production. So this is normally the blueprint for every cluster. Everybody looks at Silicon Valley and says, okay, how did they do that? Of course, they had one big advantage. In the very beginning, there was NASA and Pentagon, and took huge amounts of money to start that. But you can do it also on another level. But in general, you need something like that. And exactly what I showed you here, in these points, it's exactly what you needed, what you had at this place, not for recycling in this case, but for development of high-tech, of tech and software area in Silicon Valley. And so this is the way to develop circular regions. To give you an idea, I would like to show you some points how that can work. And let's have a look at this. Which tools do we need? Let's go back here. The red ones, I will go a little bit more in detail to these. So let's start with mass flow prediction. What is that? Imagine you would like to set up a recycling plant smelter for copper to recycle electronic waste to generate copper out of waste streams. Then you need to know how much waste can you get for your plant. In fact, the technology is not the problem, and also the question who is a customer is not the problem. The question is, how does the input look like? What are my sources? And normally you start in a way that you say, okay, I have a specific material that's going into the market. Where is it used for? For example, I have copper that I take to produce a smartphone. How long does a smartphone live? 18 months, okay. I have a certain amount of copper that is used for television set. How long does it live? Let's say 10 years. We have copper that is used in wires, for example. Hopefully they last for 100 years, something like that. And that's what we call stock and flow analysis. So something gets in here on those applications, and then it ends up in the stock, and the question is, when does it come back? And then you can say, okay, when it goes today in a building, the building will be there for, let's say, 50 years, and then it's coming back. It's going to a smartphone. Well, it will come back in about 2 years, something like that. And that's the potential flow that comes out of that. You can do that for a certain region, you can do that worldwide, and you can do that under the premises of different trade situations. For example, at the moment, we are talking about a change, big change, due to the Mercosur cooperation with South America. That means we can trade material better. This is important to generate by a system dynamics approach an idea how material flows really could look like under economic and political situations. And then you can come to the point, say, okay, I invest. Recently we had a decision because you have seen in the very beginning, for example, which country produces most waste. It's the United States. And if you compare, for example, some countries, they say, okay, there are some countries that use quite a lot of raw materials. They have a low environmental understanding. They have a high level of wealth. They have plenty of space. And they have comparatively low production capacities on hardware. Massive. The result is you waste everything. So as a result, it's typical country, it's the United States. The largest resources of copper in waste is in the United States. There are other countries like Japan, where you have the very opposite situation. They don't have any space at all. They have a huge industrial production, no own resources, no space for deposits. So you don't have to look for deposits to get to the waste streams because it's all recycled already. Taking that as a background, it's understandable that our large, the biggest copper recycling company in the world, Aurubis, from Lünen, Hamburg-Lünen, now starts to build a big recycling plant in the United States. Of course, it's investment of €500 million or more. It started €500 million. It's rather in the area of billions, and therefore you need those things because otherwise you really get stuck if you don't know what's coming up and what do the ones in China do and what are the others doing. Then, next point, navigation and control of post-consumer wastes. There are many nice points that you can follow. First of all, education is important, but of course we also need raising of intrinsic motivation, and we have, it's called decreasing behavioral costs. What is behavioral costs? Is has nothing to do with money. It's just I have to get up from my sofa and to do something. For example, if we say, well, I want to collect electronic waste, and if you give me your old smartphone, come to my store and I give you €3 for this, knowing that I just can get back 2, but I find that by this way nothing happens. If you start and go and say, okay, on next Saturday on the market, I'll change an old smartphone against a sausage, which works much better, though the sausage is certainly cheaper than those €3. And if you come to the next level and say, I have a kind of event character, if you bring that there, you will find do this and that, that's perfect, that works much better. So that's what we call behavioral costs and kind of social revenue that you get from this. So this is the point that you have to follow, and for those who are working on digitalization, it's also nice. Gamification is a nice tool to come to match these things, because if you have a game and say, okay, when I bring this kind of waste to this point, I get some points on my score and go maybe to a next level. It's nothing where you get money for. Of course, if you walk through the Harz mountains and collect the stamps for Harzer Wandernadel, whatever, you also don't get money for it, but everybody wants to go there and get their stamps. So that's what we need. That's beyond economic thing, because Homo economicus doesn't exist. Men are working a little bit different. Well, then we need the identification of secondary raw material sources and development of collection and treatment systems. Of course, it's like in the primary raw materials business, you just have to understand what sources do exist and how to treat them. And we, of course, have 3 different levels. We talk about classical, coming from down there, consumer to business, that's the waste you or we produce and bring that back to industry. We have business to business. And the latest thing is deposit to business, where we have seen how large amounts we do have in the dumps, and tailing ponds and whatever, that's what we have to reactivate. And it's always a combination of mechanical, chemical, and thermal processes that we have to run. Well, intelligent combination of dismantling, mechanical processing, pyro and hydrometallurgy have to be generated. It's complex, it's much more complex. It's kind of a neural network that you have to deal with in this whole business. And that actually makes clear that we have to end up here. That means management of complex process chains by digitalization of circular economy. It's not that easy as it may look like in the very beginning, because the question is, who may get which information? We have run these in a big project. We have run this for one specific waste stream, in this case for lithium-ion batteries. So the producer of the cell has some information and needs some other information, then the car producer and so on, and the user and the one doing repair and so on. Everybody needs information, has information. But certainly not everybody is eager to give their information to everybody else. So it's pretty tricky to have some kind of firewalls for transfer of information from A to C but not to B, and the other B to D but not to C and not to A. So it's not that easy, but we have to train the systems and we have to train the people, because that's the only way to run such systems. It still takes a while to bring this into reality, because it's not only a technical problem, but it's also a kind of mindset problem to introduce these things. Well, finally, to do this, we talk about networks and model regions, and there we are, here in the recycling region Harz. In fact, this is, well, the central region of recycling in Europe. That's not just because of us here, but this region started with this raw materials business a very, very long time ago. It's the mother of all activities is the Rummelsburg, just around the corner, the mother of all mines, as we say, 3,500 years under, more or less, under production, 1,700 years definitely, and more than 1,000 years continuously. And as a result, many, many companies for different materials set up their activities in here. And so if you take a closer look and say, okay, let's take an area like that here. What is actually done in this region? We have mining area with residues, mine tailings that have to be processed, not only in Goslar, but also in the Mansfelder Land, for example. We have smelters like in Oker, but not also here, but also here in Helbra, for example, where we have residues from smelting. We have automotive industry. One small company a little bit north of us, okay, getting smaller at the moment, Volkswagen, with all the critical lines along here. We have steel companies like Salzgitter, and so on and so on. So there is quite a lot of activities done, and in fact, since we started to set up this region, more and more companies started to put their investments in here. So as a big point was, for example, this is a plant, aluminum recycling plant of Novelis in a very small town called Nachterstedt around here. They started, and then Trimet came, and then Befesa came, and then the fourth company came, and in the end it's meanwhile the largest aluminum recycling cluster in the world. So they produce from every kind of scrap, every kind of quality. So this really gives us a challenge and a potential to do those things. So it's exactly what happened here. That's what you have seen as Silicon Valley. If you go beyond a certain amount of people or companies working on this field, it starts to generate a kind of gravitation. And very often, every second or third week, somebody calls and said, okay, well, I want to do recycling, and if I want to do this with this specific material, of course, I need a place to do this, and I would like to come to the recycling region Harz, because you are the ones who are doing that here, because we can connect. And that's really a big big advantage to work in this direction. To give you just a short idea of the most important things that we are talking about, circular steel, circular aluminum, and non-ferrous metal recycling. Here you can see a plan of the change of our big steelwork in Salzgitter, a change from conventional steel production based on coal-fired or coal steel production to hydrogen steel production. That's Salzgitter process. Salzgitter is investing for the first stage of setting up this hydrogen-based steel process. The first stage is from 23 to 26, 2.3 billion euro, just for the first stage. Well, that's quite a lot of things to do, but that also means we have to run circular activities around these things. We have, as I already said, this aluminum cluster. We have a very strong activity in OCA around non-ferrous metals, specifically the critical elements. And many companies are doing the business. And of course, it's not just one university working on that, but it's always a cluster of different actors. In this point, it's specifically our cooperation with Braunschweig and Fraunhofer IST. The cluster circular battery production, of course, triggered by this nice company over here. If you want to produce electro cars, electro vehicles, you have to make sure that you get the materials to produce batteries. Actually, you need the production of cells, of batteries, of cars, and then you have to return everything through the whole system to get back the material to produce the next generation, because raw materials are scarce. That's the cluster circular battery production, where many companies and many research organizations are involved, and that's what we want to set up. Of course, it's a long way, but we are pretty sure that we can go the way to fulfill that. Then we talk about the so-called WEHARTS cluster, WEconomy. So stands for Waste, Electric and Electronic Equipment. And what we did out of that was economy, because it's a question of an economy to run this. And of course, from here actually, a company, Ceconsoft, in former times, other small company started with generating an app where to go with your old product, not waste, but old product. And you have the complete line coming from, well, who else can use it? Can it be repaired? Can it be refurbished? Can it be manufactured or whatever? And we have partners around here like Elektrocycling, like Kreiswirtschaftsbetriebe, like Mediamarkt or PD4 Software working on that. And so that works together and starts to work out very well. Well, in this area, we also have the cluster minerals recycling and sustainable building. In fact, we have a maximum of knowledge and companies and universities that you will find in Europe in this region. This is, of course, a little bit elongated because we were talking, for example, about Weimar. It's around here, and Clausthal is around here, and Hannover is around here. If you bring this together, you'll find everything you need for a complete setup of a modern recycling system and circular economy system for buildings. So more or less, more companies come here and say, okay, there is a gap, I want to work on this gap, and that's going to work out pretty well. This has been an example for, and that's in case still the case, the first in Germany registered circular region. We are, as our region, a part of the Circular Cities and Regions initiative of the European Union. That means Circular Region Südost-Niedersachsen, Southeast Lower Saxony, and we as TU Clausthal have the lead in this business, and our focus is circular production and use. Of course, there are certainly different things that you can do in a circular region, but for our region, that's our specification, since we have On the one hand, companies working exactly on these fields. We have universities specialized on those things, like we in Clausthal on the raw materials business, developing of new products like Braunschweig, for example, to run this line. If you have other settings, you will get to other contents of a circular region, but this is the content of our circular region. And in the end, we have this Circular Cities and Regions initiative as a network of circular cities and regions. Of course, it's very interesting to cooperate with them, because if we, for example, cooperate with Copenhagen, they are pretty well organized in Fernwärmenetze. That means how to transfer heat systems for households all over the city. Well, in our region we are not very good in that, but we can learn from them. We have cities like Amsterdam, pretty good setup, for example, in logistics. We are on this part. So that's what we need to end up finally. Every region, every city is trying to optimize what they can do best, exchange, and try then to have a worldwide network and hopefully end up in a circular society and to get that operational and hopefully until 2050. Well, and so much for that, and now it's your task to develop ideas for a virtual circular city and a virtual circular region with distinct focuses, whatever you would like to, and therefore we would like to split you in two groups. One is working, just developing, just from the scratch, a circular city, and the other is developing a circular region. And afterwards, it's kind of World Cafe format that you just get your ideas, put them on small cards. We have this Moderatorenkoffer with us, and then get an idea how it's going to work and present it afterwards. And well, we would be happy to learn what circular city and circular region could be set up somewhere and what are the prerequisites to do that. But before we start, first of all, if you have any kind of questions, just go ahead. Not yet. Then I would suggest let's have 5 minutes of a break, and then we can prepare a little bit, and then we would like to split you up in two groups. And one group is developing a circular city with whatever you would love to see there, and the other one develops a circular region for whatever. I just had some. From those two charts, I've shown you just those two slides on the two tables that you can look what I have put in there. And but then it's up to you to develop something completely new.